All right, yeah, we're going to work 3 and 4 together. This essentially is saying if similar to the same thing as number 1 and 2, but it's a little different. This says W of x. That should tell you right away we're working with W of x. That's the name of the equation. There it is. But it's not telling you to insert anything in replacement of x. It's saying we want you to find x. Well, how does that mean? Because look, it's saying write down the equation, but this time we want you to replace this. Replace this entire symbol with 41. So this is the equation, W of x, but now it wants me to replace it. So watch what I do. Instead of writing W of x, I'm going to write 41 equals 4x minus 9. And now this is a normal equation. See how this 41 replaced the W of x, and I wrote down the rest of it? Now just solve this, y'all. This is not that big of a deal. I'm going to add 9 on both sides, and I'm going to end up with, what is this? 41 plus 9 is 50 equals 4x. I'm going to divide the 4 on both sides. Divide the 4 on both sides. 50 over 4, if you left that, that is mathematically correct. I won't deduce very many points from it, like hardly at all. But there is a prettier answer. This divides out by 2. 25 divides by 2 and 4 divides by 2. So when it's all said and done, you can reduce it by dividing both by 2. And that's your full answer, 25 over 2. Again, I mean, I'm more lenient on reduction errors because I actually worked in the STEM field, and I know that like if you plugged in 50 over 4 or 25 over 2 into the equations, it's still going to work. But we still want y'all to understand reductions. All right, number 4, same thing. G of x. That should tell you, all right, go find the equation named G of x. There it is, yo. And then it says replace G of x with a 25. So watch how I do this. I'm going to write my 25 equals, and what's the equation I'm using? I'm still using G of x, negative 2, 6x minus 5. And then it's saying we want you to solve for x, find x. It's like, okay, no big deal. The first thing I'm going to do is I'm going to distribute. Negative 2 times 6 is negative 12x. Negative 2 times negative 5 is positive 10. This is just normal arithmetic at this point, y'all. I'm going to subtract my 10 over on both sides. I'm going to subtract my 10 over on both sides, and I have a 15 equals negative 12x. That sounds good. I'm going to divide by negative 12 on both sides. I'm going to divide by negative 12 on both sides. And again, if you wrote this answer, excuse me, if you wrote this answer, I will take off a few points, not tons, because it's not fully reduced. We don't like the negatives on the bottoms. We prefer them on the tops or at the sides. And then this can reduce by 3. What do I mean by that? 15 divided by 3 is 5. And then the 12 divided by 3 is 4. And then that negative, you can put it to the side or put it on top. Again, mathematically, if you were to insert 15 over negative 12 into a program, it would still work. It would still work in equations, but this is for the human side of it. So this answer is for the technical side. This is for the human side. And that's 3 and 4.